and which is the final circuit. So we'll be discussing about final circuit tonight.
Welcome to use valid product. Bluetooth
And
mode.
that will be our last class on the electrical aspect. So we'll be discussing about final circuits and what does our final circuit entails. Anyone with idea? If you are talking about final circuit, what do you understand by final circuit? Anybody?
Hello, sir. Can you hear me, sir?
Yes, I can hear you.
So, when we are talking about final circuits when it comes to electricity, it refers to the final point where the load is going to get to. And it's more or less like majority of the time it refers to our outlets, electrical outlets from the primary equipment to the terminal equipment and to, of course, and when we are talking about final circuits, we are more or less talking about points at times, lightning points or maybe
Switches
lighting
and
points and all, switches and all. So according to the knowledge I have before, it is usually about the wires, the connection, the wire that are connected to this terminal equipment from the primary equipment, and they are measured with along with their switches and their sockets too. So that's my knowledge of primary equipment
nice
of
one.
final circuits.
So any other idea? Any other idea about final circuit?
It's the same idea that basically our points, and sometimes our final circuit also include like either circuit breaker or field.
So how do you determine that?
Sorry, so how do we determine what, sir?
How do you calculate your final circuit? Any idea?
Sorry, sir.
Yeah?
Sorry, sir, what was your
I said, how do you calculate your final circuit? How do you determine your circuiting? How do
okay?
you
I think
determine your
I'm not
circuiting?
I'm not sure, but I think we separate them from lightning and power. So based on the number of points and the number of type of switches that is or sockets that is connected to it, that's what differentiates their measurement. So we count them based on number of points. That's the knowledge that I have about that.
Okay, now. Any other idea?
That's the same idea. So I always calculated as points from how I so
Okay, now I will display a drawing now. I will display a drawing. So we now determine the circuiting. Mr. Jami, I'm sending you a document. Inside that document, there is a particular this thing inside.
Okay, sir. Okay, sir.
I've sent it to you. I've sent it to you now. So now
Okay,
I will
sir.
display a drawing. You can send it to the group that they can have. So this is my drawing now. This is my drawing. Can you all see my screen?
Yes, sir.
Yes, sir. Can I have your time? Yes,
I'm trying to. I'm looking for this thing. Can you see my drawing now?
Yes, sir.
So in this case now,
I can see your drawing, sir.
how did I determine my circuiting for this drawing? How did I determine my circuiting for this drawing?
Okay, I think for the connection points that are connected to each other, you have to first identify if it's a lighting point or a power point. Then after you have established if it's a lighting point and a power point, you select you if it's a lighting point, you count the number of points, then you check which switch is connected to it if it's a lighting point. Meanwhile, if it's a power point, you check which socket is connected to it to describe it when you're after you're done measuring.
Okay, Mr. Damian. Any other idea? We are all in class to learn. There's where I'm taking you to. Oh yeah. Oh yeah, oh yeah. Any other idea? Any other idea? Any other idea?
no, sir.
You can't come here. Okay, Mr. Jami, were you the one that spoke the last time?
Yes, sir.
Now, when you are determining your final circuiting, final circuiting is like connecting 5 lighting points. And how do you connect light to that your 6 lighting points you have connected together? That's when your circuiting will now comes in. And how do you determine that circuiting? Ask me how.
How?
You
How,
don't need
sir?
to disturb, you don't need to disturb yourself. Just go to your DB layout. Your circuiting has been calculated there. Let's go. You see my screen?
Yes, sir.
Yes, sir.
Now you can see where they wrote 10 amps. Actually, sometimes it might not be. Actually, most times they usually show it like this. But the best thing you can do is go to your layout, as in your lighting layout. Count the numbers of L1 as in lighting point, and where is it linking to? That's what Jamil is trying to explain in this case now. It's like you have 10, how will I call it? You have 10 lighting points being controlled by a switch. It shows that that's one circuiting. Are you there with me?
Yes, sir.
Now, it is from that switch that it will now be linked up and will now be taking it to your DB. That's where you now see that in your DB, you will see that, okay, some particular breaker is meant for your lighting. Some particular breaker is meant for your power. Are you together with me? Now,
Yes, sir.
look at my screen now. We have different DB here. But I'm just taking this DB as an example. Now, you know that in your first floor or thereabouts, you might be seeing like 4 dB. 4 dB controlling first floor or thereabouts. It depends on how it's being calculated.
Okay.
The easier way you can do go to your DB. Can you see my DB here? How many lighting points is on my L1? How many lighting points is on my L1? Hello, are we there? How many lighting points is on my L1?
I will see you.
How many lighting points is on my L1?
That's 16 plus 2 plus 2 plus 2. That's
22.
22, sir.
In total,
22. Yes.
22, but we still have 15 or 25 numbers.
Yes.
Please, who is that person that this thing is not muted?
So it should be around 48, sir. With the 25 and plus the 1.
Okay, now
1 by 15
let's not
watts.
try and go to our layout itself, lighting layout, and let's see maybe that is how it's being run before we are sure of what we are picking now. Can you see my screen now?
Yes, sir.
Now you can see where they wrote CSL1. Hello. Let me zoom. Can you see where they wrote CSL1?
Yes.
Now look at that area now. Look at the numbers of lighting points and being connected to a switches. Are we there? Hello.
Yes, sir. We are
Yes,
with
sir.
you,
We
sir.
can. Yeah.
I said, can you see the numbers of CSL1
Yes,
in
sir.
that
You can see.
valet parking?
Yes, sir.
If you count of CSL1 and now count the numbers of lighting being connected to a switches, let me try and get the dB they are using here, so that we be specified which of the dB are they using. Sorry, I want to try and locate the dB they used here, so that we'll be sure of. Why is this one disturbing me? Sorry for that too. So I'm looking for the power layout. The power layout will give me the annotation of which dB are we using. Sorry, I'm looking for the power layout in the drawing so that we know which of the DB is it linking to. Where is the DB? Let me see, maybe what is the annotation for DB here? Hold on, I'm trying to look for the where our DB is being positioned. Sorry, I'm trying to look for where the DB is being positioned. I think the DB here is not showing. I'm not sure they designed the area they want to position the DB.
I don't think it's shared this 33 pages drawing.
Yeah, that I want to look at where the positioning of the DB to know. Okay, don't worry. Let's go to our DB scheduling now. So from our DB scheduling, we now pick it from there. Now you can see my screen now. You can see that we have L1, PA/L1. Can see the numbers of lighting fittings being connected to this L1. So it shows that in this case now, about 22, 24, about 34 lighting fittings connected to a particular switches. And how many switches do we have here? Now, sometimes you might not use your DB scheduling now. You might go to your layout and see, okay, L1, how many L1 is connected to a particular switches? That one makes your circuiting in this case now. Are you there with me? Hello?
Yes, sir. Yes, sir.
Okay, let's just try and let me go to page lighting layout. Or I should just try and look for a particular drawing that has the numbers of that it to be useful than this one that is not even showing. Okay, I'm trying to get a drawing now so that it will be easier for us to understand what the circuiting entails. Engineer Mojid. Most times I'm trying to look for a drawing that is not being jam-packed. So I guess let's go by this drawing itself. Look at this valet parking. We have CSL1. That CSL1, you can see the numbers of lighting fittings that is being linked up to your switches here. Can you see my screen? Look at this CSL1 now. This CSL1, you can see that the total numbers of switches here are being linked up to a particular switches at the door here.
Yeah, I think it's been linked up to a one gang one way switch.
God bless you. Now, there's sometimes whereby there might be a looping at the end of the, but me, I'm not seeing a looping here whereby we can tap from one switch to another switch. Have you seen that one before?
So do you mean the same lighting points, but they are going to have two switches, one at the down and one at the top, like an hostel setting?
No, look at this door area now. You can see the door, this particular switches in front of the door and one at the back of that door.
Yes, sir.
So sometimes they might be doing a looping, but I'm not seeing it as a looping in this case now. In as much everything is being categorized separately in this case now. Are you there with me? So that one is one circuit thing. Are you there with me now?
Yes, sir.
Now we have how many lighting points do we have? You count the numbers of lighting points you have, and you calculate you count the numbers of light fittings that we have here. Are you with me?
Sir, I noticed something on the drawing now. The same lighting points, but they are different. There's a different lighting fitting. That core A area. Is that also CSL1? Yes, it's also a CSL1. In the core A area, also a CSL1, but it's a different lighting fitting.
It is a different lighting fitting. Can you see that? No, the lighting, that item now. Do you know the meaning of looping?
No, not really, sir.
Do you know the meaning of looping?
Not really, sir.
Hello.
No,
Hello, sir.
not
Can you hear
really,
me?
sir.
Not really, sir.
Do you understand what is meant by looping?
No, sir. Not really, sir.
Now, when it
No,
comes to
sir.
looping, there are sometimes whereby you divided that C1, so the one at that core A area is just a wall. Oh, his box is just like being back to back, but just like a tangential. In that case now, it can be tapped or it can by I receive light from that valet by switches and not tap from it so that it can feed that CSL1. Are you there with me now?
Yes, sir.
Hello.
Yes, sir. We are with you, sir.
Are you trying to get my explanation?
Yes, sir. Yes, sir.
Yes, sir.
Sometimes we might get to site and they will be looping based on the switches are not far from each other. You can see the switches at that core area. It just it's not even up to 25 mm distance from that valet parking area. So in this case now, it can be looped, whereby the one on that valet area can be on that core area before it's being directed down. Are you there?
Sorry, sir, your end is breaking. Can you please repeat what you said?
Hello, sir.
Listen very well.
Hello, sir. Can you hear me,
This one
sir?
is this thing. You can see valet parking. You can see where the switches is and the core area where the switches is. Do you see these two switches?
Yes, sir.
Yes, sir.
Do you see these two switches? Whereby you can tap from this, you can tap from these switches and electricity will now be feeding the other switches and still serve as one circuit. Hello, are we there?
Yes, sir. I will see, sir.
Yes, sir.
It's a pity that we didn't have the DB. I don't know which of the DB is feeding this one. If it to be like
Yes, sir.
that, the DB now, we'll have seen the circuiting in the DB.
Hello, sir.
Hello, I can hear you.
Sir, what you are saying that instead of the circuit now originating from another switch,
Yes.
for the CS1 that's inside the core A area, if it's
Yes.
looped, it is going to continue from the switch that's in the valet parking area.
Yes.
Okay, noted, sir.
So you can't compare drawing and execution. When you get to site, sometimes you see that generally will tell you that these boxes are not far to each other. Let me just look from here and use it to feed this one before it will now be directed down to the DB. Sometimes it might be feeding like two nearest boxes before it will now be directed down to your DB. Are you getting my explanation?
Yes, sir.
But the easiest way you can do is by taking your DB. Your DB will tell you, okay, this is my circuiting. How many light fittings or how many cable will be linked, and it will not be coming to my DB. You can see my DB here. You can see where they wrote L1, L2. It shows that two lighting fittings, two lighting are coming into the DB. So it now depends on how they are being connected to each other, whereby it will now be diverted. Maybe so segment A, you see that, okay, these lights are on the same area, but it will not be looped from A switches to B switches to C before it will not be directed to your DB. Are you there with me?
Yes, sir.
Now, circuiting has been solved. All other items in electrical are just basically counting. Are you there with me? We've done our permanent equipment, we've done our terminal. Now, switches and sockets, all your lighting fittings, you just count the numbers of lighting fittings you have. Which type of lighting fittings? Is it 10 watts? So ceiling mounted, you specify it. Is it 20 watts bulk head? You count it. Is it 30 watts, 2 by 40 watts, so ceiling rows, you now count them. Now, you now count the numbers of switches you have. One gang, one-way switch, you count them. One gang, two-way switch, you count them. Three gang, two-way switch, you now count them based on the symbol you are having. Now, remember one thing, that your cable that will be used for your lighting, that will be used for your lighting is what? 1.5 mm cable. For your switches, I mean for your, my data has finished. For your, how will I call it? For your socket, use to 2.5 mm cable. But for your AC water heater, you use 4 mm cable by 3 core. As in you just have, you have your red, your green, which is your earthing, and you have your neutral, which is your black. But when you are having, like, let's say you have your cooker unit in your kitchen, you use a 6 mm cable. Sometimes the electric and you want you that in I con I
Is it my network or can anyone hear him?
I cannot hear him also.
I
We
think
can't
his
hear him.
network.
I think his network is bad.
Yeah, it's probably when his
Maybe
data
the
finished. We join back. I think his data finished when he said his data finished. Let's just hang on for a while.
okay.
Okay, by the way, I think I should just send in the attendance link for us to start filling. In the meantime, that is not yet. Yeah. So as usual, the way we do it, I'll send the attendance link to the I'll send the attendance link to the chat. So just copy the link and put on Chrome. Don't put on any other browser. Put on Chrome, fill the attendance and submit. Did you hear me? I'm going to be putting the attendance link on the chat post. Kindly fill the link. Kindly fill the attendance on your link. Thank you. Let's just hang in there till when it comes back. Please let's keep exercising patience and when it joins us back. Thank you. So our tutor was having issues accessing his bank to do sub, and I've assisted him already. So you should be joining us in the next 2 minutes. So please let's just hold on. Thank you.
Can you hear me?
Yes, sir, we can hear you, sir.
Yes. So sorry for that. This
People
got
can hear you.
exhausted. So I just have to find solution to it. My monthly. So like I was explaining, I was able to establish your final circuit, and there's no big deal in that one. So after that, now you want to calculate piping. Can you please call me back by 8 p.m.? Yeah, thank you. So sorry. So now you want to cut the, we've already established our circuiting, and I've already send a note concerning that with a small drawing. You can just go through it. Now you want to, like I was saying, you have to calculate, the remaining one are just counting an emitter. You count your lighting fittings. Your lighting fittings have different wattage and different. You see 20 watts ceiling mounted lighting fittings. You count it. You establish 3 by 30 watts. How will I call it? Bulk meter, bulk head lighting fittings. You count it. 15 2 by 2 watts ceiling. You just have to count the numbers of lighting fittings you have. Now, after that, remember that 1.5 mm cable will be used for your lighting. 2.5 mm cable will be used for your switches, for your socket. Your AC, your water heater, you use 4 mm cable. Are you there with me? Let's say you have your kitchen now, your cooker unit, you have to use something called 6 mm cable, because that one it has an higher rating in this case. Now, are you there with me? Now, you want to calculate piping for your lighting. Your piping usually use your lighting usually use what? 20 mm conduit piping. Now, you now determine what is the average distance you want to use for you just pick your shortest distance, your longest distance, and the medium distance. To divide it by 3, they give you your average distance per lighting fittings you want to use. Now, for me, I usually use 4 meter for my piping for lighting. I just say how many lighting points sometimes I use 5 meter. Actually, it depends on the design, and it depends on functionality, and it depends on which type of building are you dealing with now. Now we now say, okay, how many lighting points did I have? 100. What is my average distance? 4 meters. Now be 4 times what? Times 100. We equate to 400 meter, 20 mm conduit pipe you want to use. You now look at your switches. Remember that, no, sorry. That 4 meter will have, we have an excess that will have cover for your piping that will be going to your switches now. Now you now want to calculate your socket now. All this your double to 13 amps, the double socket, 13 amp single socket, 13 amps raw power. Now, what is the average distance? You know, in electrical, there's something called radial circuit, and there's something called ring circuit. I will try and send a note on that one. Now, from one socket to another socket, we usually use 8 meter for your conduit piping. Now, how many sockets do you have? Let's assume you have 250 sockets. It will now be what? 8 meter slash 50. We give you the numbers, we give you the total length of your piping. Now, remember that we also have your what? Your AC switches. Okay, so your AC switches and your AC this thing will be measured alongside. Now, you can also use 8 meter generally in that your area now. You have total numbers of your sockets, both your AC, your raw power, and the likes. You calculate the numbers of the sockets times what? 8 meter. Now, for your cable and your lighting now, I use 5 meter per cable containment. But remember that for your cabling, you have to allow for termination. So I use 6 meter. Sometimes you can even use 5 meter. Sometimes your cable containment might not be even up to 3 meter. While your cable will now be 4 meter. Sometimes it might not be even up to 2 meter based on the distance. There are some rooms whereby you might have like 8 lighting points, and from one distance to another distance might not even be up to 2 meter. But me, I'm using 4 meter for my cable containment, and I'm using 5 meter. Now you have 100 lighting points. Remember that we will have 3 cable passing through your what? Cable containment. Now you now have 5.0/3 because we have your red, your neutral, and your earthing. Your earthing is your green. Slash, you know, we'll be having 3 core. It will now be 5 meter/3 slash numbers of the light fittings you have. That one will cater for your what? For your lighting. Now, for your socket now, you know our socket now has different rating. You can't compare socket of 15 amps or socket you just want to plug your phone and the likes. We use 2.5 mm cable now. Now, you know, I established that we have 9 meter, 8 meter for my cable containment, but for now my switches, you now use 9.5 meter. 9.5 meter slash 3 core slash numbers of switches. No, numbers of sockets. I'm not talking about AC sockets or AC switches or your water heater switches. That one has its own cable you'll be using. You now establish that actual length. We have 9.5 meter slash, please kindly just jot this one down. 9.5 meter slash 3, which is 3 core, slash your socket we have. Now you now go back to your switches now. Your AC switches or your AC switches or water heater, we usually use 4 cable because of the rating of your AC now. Now, your AC switches also will now be 9.5 meter slash 4 3 jare slash numbers of AC switches and numbers of lighting. No, I said no, numbers of AC switches and numbers of what? Numbers of your water heater you have and numbers of your what? Cooker unit. Okay, let's just say AC switches and your water heater switches. You calculate that one. Now you now go to your cooker unit because your cooker unit is what 45 amps and you can't use 2.5 cable. Sometimes you can manage and use cable, but me, I usually use what 6 cable. But based on what this side is doing now, we are being told that we'll be using 4 cable. So it shows that 9.5 meter slash 3 slash numbers of cooker unit you have in that area. You have already sorted out your 1.5 cable, 2.5, 4 and 6 cable. You know, some few weeks ago, I was able to teach us how to calculate your power cable. I mean, cable from your transformer to your panel and to your DB. Are you there with me? Any other
Yes,
question?
sir.
Any question? You can see
Yeah,
that.
I have a question.
Okay, I'm
Good evening,
listening,
sir.
sir.
I have a
Yes, sir.
question.
Yeah.
So currently, I'm on a project, and I realize when they are drawing their lighting cables, that's for what's it called? That's for the light. They use
Yes.
more of red than other colors. Is there any reason for that, sir?
Yes, there's a reason for that. You know, like I was saying now, you can't compare what is that you're drawing and how it will be executed on site. You know, we now see the best drawing you can use that will show that you need to use more red in this area is when you are calculating, is when you have your workshop drawing. Your workshop drawing, there's sometimes whereby you will even have like 6 cables running in one pipe. Have you seen that one before?
Yes, yes, sir. Yes, sir.
You can even see 6 cables. When you now get to a particular place, it will turn to 3. Are you there with me? It is based on functionality, and it is based on how they want to run it. In this case now, the reason why is that there are some areas whereby you just want to loop now, or you want how will I even put it? Gone safe. As it has some different branches now. Now for you, there's something called cable management, and for us now to be having from one point to another, let's have to 3 runs. Getting to another point now, you have another 3 runs. Now for us to have a proper cable management now, they now tell you 6. That 3 will now be branching. When it get to a particular place, it turn to 3 runs before it now enter your DB itself. The best way, as in the best drawing you can use for that one is when you have your own workshop drawing. Your workshop drawing will tell you, no, from this location to another location, you are using 6 cables. And even in that cable, you might be even be seeing 3 red, or even 4 red, 1 neutral, and 1 netting. Are you there with me? That's why most times when they want to give you, let's just say, just call an electrician, you can't see him having 10 red, 10 10 black and 10 earthen. No, don't. The red will be much. The earthen will be small. He may tell you, give me 5 earthen. Give me to 13 red or 14 red and 11 black. Are you clear with me? Hello.
Yes, sir. Yes, sir.
So I hope I answered your question. Sometimes you can even ask for this electrician. They will give you more explanation of why are they running 6, why are they running 3 here. Though there's something you call do incoming cable and there's something you call do outgoing cable. Now, in that incoming cable and outgoing cable, they might use 3 making 6. In this case now, there's some areas whereby you only have an incoming cable and you're not having an outgoing cable. That's where you now have your 3 core, 3 runs, red, your black, and the what, and the earthing. There's some place whereby you might be having outgoing and incoming. Outgoing means it's coming from a particular area, coming from a particular lighting point, and you now have an outgoing. Outgoing is your supply now. Now you want to tap from this lighting A to your lighting B. 6 cables already from 3 cables already passed, but you want to supply, you have another 3 cable making 6. So we have the outgoing and we have the incoming. There's some areas whereby you might be using just only 3 cable alone, which is your red, your black, and your earthen, which is your green. Are you there with me?
Yes, sir. Yes, sir.
Where you show this electrician, they can give you more insight of why there isn't much red here. Why do we have 6 runs here? And the other place we have 3 runs. The other place we have 3 runs. You understand what I mean? Hello, any other question? Any other question? Hello, any other question?
No, sir.
Any other question? Madam Ayomide, any question?
No, sir. No, sir.
Madam Janet, any question? I can see my friend Jemima, any question? Madam Kemi, any question?
No questions, sir.
So, if there's no question, I hope I've been able to justify myself under electrical. I can't teach you everything when it comes to electrical. I can't. You tend to learn on every project. Tends to learn on every project. So, any question before we call it a day? Any questions so far on what we have been teaching? And okay, I have issues here. I have issues here. I have issues here. Yes, I
Hello,
can hear
sir.
you.
I think if they have any question, they'll just tag you on the group chat and ask you on the group chat.
Okay, I want to show us something. And let me see who will get this answer. Let me display that drawing. This is the drawing. Now, hold on. I want to see the idea of. Now, can someone interpret the drawing for us? I'm talking about the incoming. Incoming. Now, can someone interpret the incoming for me? I'm not talking about the outgoing now. What is the rating of my incoming and how many incoming did I have? Oh yeah, oh. There's money on it too. Can someone interpret the incoming for me and the outgoing of this panel? Majorly that incoming. I want to see what people are thinking. Oh yeah, I'm listening. Oh yeah, now should I call names? Should I call names? Madam Ayomide, can you interpret this incoming for us? This panel. I'm not talking about the farmer equipment. I'm talking about this panel itself. What is my incoming? Yeah. And what is my, how many outgoings do we have? How many incoming do we have?
Sir, I think for the incoming.
No, Mr. Jami, don't answer this question. Don't answer this question. I knew that I've seen some people here that attended this class, and Madam Janet, during class that day, I'm not seeing Grace online. Madam Ayomide was online. Ayomide, can you please interpret this thing for us? Please, let's be fast. I have a meeting by 8 p.m. Please, let's be fast. Oh, yeah.
Okay, sir.
Okay, I'm listening. And do we give me the reason why behind it? Oh, yeah.
The reason
Oh, yeah. How many incoming do we have? And in this case now, and tell me the rating. There's something I just want to fight on from this area.
okay, I think we have about is it 2 incoming. I'm saying
Why 2 incoming? And what is the rating? You must give me the reason why it is 2 incoming.
because the first one I'm seeing is your PHCN3 phase energy demand meter, and the second is this generator with 50 kVA 415B, sir.
So why is it 2 incoming?
I can't really see the other one at the bottom, but since the other ones diverge into 1 point to the changeover switch.
Okay. Yeah. So you said you have 2 incoming, but 2 incoming, Abi?
Yes, sir.
Okay. Any other opinion? Any other opinion? Any other opinion? Okay. Actually, she's right in this case now. And she got it right. I have a small gift for you. The reason why we have 2 incoming here, which is 400 amps MCCB, 40 volt, 4 pole, 2 numbers, is because of we have 2 generating source. Now, when it is 2 generating source now, the one coming from the generator is not linking with the one coming from our direct current. If there to be that, our direct current will be dropping inside your changeover switch before a particular cable will now take it down to our incoming. But look at this case now. We have 2. That is to say, we have 2 incoming. 1 incoming from your generator and 1 incoming from your what? From your direct current. The reason why they have this changeover is just to control your generator when being used. When there is no light, you just go to your generator, switch it on and on it, except you have a synchronizing panel. But now, when you change this changeover to neutral, immediately there is light here. So that was the reason why we have two incoming in this case now. Do you get my explanation? Hello? Do you get my explanation?
Understood, sir. Yes, sir.
Do you
Yes,
know
sir.
do you know
Yes,
the reason why? If you look at that changeover switch, if there to be that cable coming from your metering system does not go into your your panel directly, it shows that we have one incoming. That is where you now see that cable will now enter our generator cable, we enter our changeover, and the low lighting cable coming from our pole or from my metering will now enter our changeover. In case there is light, I change from generator to light. When there's no light, I change from generator to light to generator. But now that it has been splitted, it shows that we have two different incoming. One incoming for the generator and one incoming for the what? For the DC current. Do you get my explanation?
Yes, sir.
Do
Got
you all
it,
get
sir. But sir,
do you all get my
this sir,
okay, I'm hearing.
this mechanical interlocking or system interlocking system,
Yes.
it's connected between those two incomings. So
Yes, it's connected between those incoming. Why is that? Why is that? That
that's what I'm
mechanical
asking.
interlocking incoming is like a copper this thing. There's the way they usually build this panel. I will try and get a picture. I think when I send a picture of panel, I think when I send a picture of panel, I will try and get the inside the panel whereby we have two incoming and being leaked. Now, if you look at all this incoming now, majorly they are copper, pure copper is being used. Now, so do you now see this mechanical interlock? It's like a looping between two it is a looping between two incoming. Are you there with me now? It's just like one is tapping from B. Are you there with me now? Are you there? Are we there now? It's like one is tapping from B, and for one to we are now using changeover to control it. When there is light, automatically as you are changing your changeover, hello? Yeah, good evening. Are we still using are you still using the same link you sent to me? Sent to me yesterday. Okay, yes. I will join now. Give me two. Yeah, thank you. Hello.
Yeah, with you, sir. Yeah, with you, sir.
Do
Yes,
you
sir.
understand my explanation? That one
Yes, sir.
MCCB, that incoming for that generator is being controlled by what? Changeover. Until you switch from the changeover to generator, that's when that incoming will start functioning. Are you there with me? That incoming does not have a light until you switch it to generator and your generator is on. But when your generator is not on and your changeover is in neutral, that your incoming is not working. It is your incoming for the light that is working. Do you get my explanation now?
Yes, sir. But
So,
sir,
okay.
when it is being changed to generator, it means the incoming for the light too will not work again.
No, that's when that's the mistake you will not do. Are you getting me? So that both of them will not be triggering. Are you getting me now?
Yes.
There's a way it will be connected that both will never be affected. Are you there with me now?
Okay.
I'm not the panel builder now. This panel will be built by a specialist. And when he is being built, that is where we now have our mechanical interlocking system control, whereby it now control both. Are you tell with me now? If there is no mechanical interlocking system control, it will now be like, you take your neutral wire, neutral cable, and your live cable, turn it together. You know that there will be spark. Are you telling me now? Now,
yes,
that mechanical interlocking is the one that will now control that there will not be triggering between incoming for generator and incoming from light.
Okay, sir.
So that those they will not be affected. That is why they bring in that incoming mechanical interlocking system and control. You can search it online. It will give you the function of why we are having mechanical interlocking and the likes. So, any other question? Any other question, please? I have a meeting. I need to join now. I'm already online already. I'll switch. So,
Well, sir.
any other question? So, I hope I've been able to answer our question tonight. And I've been able to touch, if not 100% of electrical, but I've been able to touch the major part of electrical. Now, it is now for yourself to now build up yourself. Build up yourself whereby you now continue in the race. Me, I usually tell my student that I was being introduced to MIE when I was in my 400 level, and today, I'm being paid more than, I won't tell you, I'm being paid more than $500,000 as an MIE QS. And I'm still requesting that increase my salary to this amount, close to $1 million. So it is based on, I'm focusing in an area whereby people are not much. But you can see this building, now. This building, is common. You can even see QS in building today. I know how to do building measurement, civil measurement. But when it comes to MIE, it's being done by the QS specialists. And these are people that are not much. So if you are interested in MIE, you'll be paid well at the end of the day if you know what you are doing. Any other question before I call it a day? I'm already in a meeting already, so I'm just trying to switch from one meeting to another meeting. So if there's no other question, can we call it a day? And if you have a question, you can just drop it in the chat box of the group, whereby you can just tag me, so I'll put an answer to that. Can we call it a day?